Okay, in this video, we briefly review Fourier series. So we consider a function f of t with a period of 2 pi. For such a function, we can define its Fourier coefficients. For any given integer n, we define the coefficient as this integral. So we multiply the function with this factor, exponential of negative I n t, where I is, of course, the imaginary unit. Now, by using these Fourier coefficients, we can define the Fourier series of the function f of t. One important question in Fourier series analysis is whether the function f of t is equal to its Fourier series. Okay, let's start. Okay, let's dive into an example. This is called a trigonometric polynomial. Here, each Cn is a complex number, and we multiply that by this factor, e to the power of I n t, and sum these terms from n equal to negative n to positive n. So, of course, this n is a positive integer or natural number. So, the question is, what is the Fourier coefficient of this function for each integer n? But before calculating the Fourier coefficients, please note that this function has a period of 2 pi because of this factor. Just in case you're not sure, let's try to calculate this. T plus 2 pi. So that is this summation, Cn and exponential of I n t plus 2 pi. But this one, so let's consider only this part, and ein t times ein 2 pi. But this one is equal to 1. So this is equal to Cn e to the power of int, which is equal to f of t. So 2 pi is indeed a period of this function, irrespective of these coefficient Cn's. Now, let's calculate the Fourier coefficients. F hat of n, according to the definition, is 1 over 2 pi. Integrate from 0 to 2 pi, and f of t multiplied by exponential of negative I n t dt. Now, plug in the definition of f of t, 2 pi, so sum over m from negative n to positive n, cm, and exponential of imt times exponential of negative int dt. So since this is a finite sum, we can switch the order of integral and the sum. So sum first, and we can take this cm out of the integral and combine these two exponentials, n t dt. And we know that this integral is equal to 0 if m is not equal to n, or it is equal to 2 pi if m is equal to m and n are equal. So this becomes Kronecker delta, m from negative n to positive m, cn times Kronecker delta m n. Okay, now n can be equal to one of these m's if this n is between negative capital N and positive capital N. So this is equal to Cn if n is between negative n and positive n. Otherwise, this n can match none of these m's, so the result is 0. So otherwise. So that's it. So now, using these Fourier coefficients, let's construct the Fourier series of the original function. So that is, let's write Fourier series as S of square bracket of f of t. Okay. So n varies from negative infinity to positive infinity, and f hat n times exponential of I n t. So that's the definition of the Fourier series of the function f. Now let's plug in these Fourier coefficients here. So since the Fourier coefficients become 0 outside of this range, so we limit the sum from n equal to negative capital N to positive capital N and Cn and exponential of I n t. But this is identical to the original function f of t. So to summarize, the original function f of t is equal to its Fourier series. So that is when the function is a trigonometric polynomial. So in this particular case, when the function is a trigonometric polynomial, each Fourier coefficient, this one, is equal to this coefficient of this weight of this complex valued exponential function. So the Fourier coefficient can be considered as the weight of this factor in this function. Okay, and we want to extend this idea to any function that is not a trigonometric polynomial. For any function f of t, if it is equal to its Fourier series, like this, then we say this function is Fourier series expandable. And here is an important theorem about the pointwise convergence of Fourier series. Suppose f of t is of class 1. That means it is continuous and its derivative is also continuous everywhere except for finitely many points. Then the Fourier series of that function at t0, some point, it converges to this quantity. That is the average between the left limit and the right limit at t0. Here I don't give the proof of this theorem, but I have another video for that, so please watch that for the details. Okay, now consider this example. F of t equals to either t when t is between 0 and 2 pi, including 0, not including 2 pi, or equal to 0 when t is equal to 2 pi. So this function looks like this. It's 0 here, and it increases, and at 2 pi it becomes like this. And we can consider this function as a periodic function by repeating this shape over and over, and so on. And let's find the Fourier series of this function. Okay, when n is not equal to 0, the Fourier coefficient becomes, so 1 over 2 pi, integrate from 0 to 2 pi, and t, and exponential of negative I n t dt. Okay, we can use integration by parts. So let's see, t and I negative I n t over negative I n from 0 to 2 pi minus e I n t over negative I n dt and 2 pi and let's see, 2 pi. And if we put 2 pi into here, that's 1. So it's 2 pi over negative I n. When we put 0, this should be 0. Okay, so this one negative, negative, so that's positive, and let's see. So, okay, negative in squared, and negative int, 0, 2 pi. And if we put 2 pi here, that's 1, and 0 here, that's 1. So this term should be 0. And we cancel these, so that's 1 over negative in, that is I over n. Okay, so when n is not equal to 0, this is the Fourier coefficient. And when n is equal to 0, and f hat of 0 is t and 1. So exponential of I0 t. So this is just 1, right? So that is t squared over 2. And this, so 2 pi squared and divided by 2 pi and divided by 2, that's pi. So the Fourier series of this function is equal to pi plus sum of n non-zero, I over n exponential of int. And according to the previous theorem, this, okay, let's see, this function is continuous everywhere except for this point and this point, right? So this is equal to t if t is not equal to 0 or 2 pi. Or it's equal to, so it's equal to the average between the right limit and the left limit. So the right limit is 2 pi and the left limit is 0. So if you divide by 2, so that's pi if t is equal to 0 or 2 pi. Okay, that's all for this video. See you later. Thanks for watching. If you like this video, please hit the like button and subscribe to this channel. See you next time. Bye.